Really can't tell if you did it by hand or by calculator because it's just a one-for-one element. So, any questions on the multiply? How to get the result? No? Good. And again, this was a big one. These guys, this one was undefined.
Go back to the last one.
Uh-huh. I'll have to do them out because you can definitely see your pattern in them. So right away you know which one was off.
Yes.
So, if you struggle with it. If you're okay with it, and you can always check when you multiply, go back to just that area and do that row or that column over. Okay, now these guys. These are like your x and your y's. This is like saying negative x plus y equals 4. Negative 2x plus y equals 0. That's all it was. These are just considered subscripts. So when we subscript through, we just label them. What we wanted you to do is take these apart. This is your coefficients, A. This is your constant, B. And this is your result. You're just going to separate these. And a lot of books work off of this. This is technically the concept of the way matrix works. But we're just going to do an RREF on the whole thing. And we're going to get your answer. And so your answer, you just give like this. And technically, that's all you really have to do is just do your answer. Technically, if you took this guy times this one, you would get A times X equals B. You would get this guy. Just another way to write it. A lot of books, when you go to college, they do subscripts. They don't do X, Y, and Z. The concept of subscript also makes a little bit more sense when you do your matrix, because that's the order they come out in. We say put your letters in alphabetical order. This way we keep track of them all. But technically, subscripts is the way to do that. X1, X2, X3, X4, as many as you're going to get, rather than keep your variables in alphabetical order. Subscripts just kind of, you just kind of have to keep track of them a little bit. If you want to change them to X, Y, Z, if it helps you, change them to X, Y, Z, just to get them out of there. Again, separate your coefficients from your constant. Your constant is considered what it's equal to. That's your constant. Put your result in your X. RREF. This is what comes out of this. This is your answer right here. Just separate that into an X. And if you multiplied X times A, you would technically get B. Just another way to look at it. Good? Okay. These guys, again, we're just asking you to just take a look at, can you do this? Adding and subtracting, they have to be the same dimension. Multiply, they have to follow the rule. So can you do it? Can you not do it? Associative property exists for multiplication, but not commutative. Let's see if these make sense to you. Do you have this problem on the bottom or no? No. Okay, we're going to do this problem over here. So let's find the solution set to this guy. Alright, so set this up, do an RREF, and let's print out what you get for RREF. And you should come out with now, normally we're looking for this. We're looking for this diagonal. X is on, Y is on, Z is on, but Z didn't go on. We ended up with all zeros in the bottom. So like we talked about yesterday, this is your end solution. So do you remember how we started it? Your infinite solution, or any answers. We started it here. C can be any answer, any integer. And work your way backwards. You're going to solve in terms of A. So this equation, this is your x, y, z. Or if you wanted to, x1, y, x1, x2, x3. That's where the subscripts come in. So if you took this, this is y minus z equals 0. So we substitute in. I don't know if this is the one we did yesterday in class. So y, it looks like it is. So y is equal to a. Then go to the next equation. X minus 2z equals negative 1. And substitute in the a. This is the one we did in class. So subtract, you're going to solve in terms of x, because you want it to be in terms of a for x. So you're going to add this guy over. Or you could write it 2a minus 1, if that looks better. I don't think we did this one in class. This is different. So there's your x, there's your y, and there's your z. When a is any integer. Okay? Just so that you're a little familiar with that. How would I set this up to put this in my matrix? If I'm going to set this up, this guy has to follow the same pattern. So I'm going to have to subtract y and line them up. You have to make sure, that the x's and the y's are lined up. So you're going to have two equations. And you're going to put it in your matrix. And you're going to see if you come out with the same answer. I mean, some of these would probably be simpler to put in, just to substitute in, rather than go through all the trouble of your matrix. But I want you to kind of get used to putting it in a matrix, setting up your parts to it. Am I in your way? What's the dimension of that guy? 2 by 3. Just do an RREF. You don't have to back substitute. Now the nice part about this, it's very hard for us to go back to the fraction if we did it this way. But can you go back to a fraction? Yeah, sometimes you will be able to, sometimes you won't. But you can also bring these back to a fraction. Do you get the same answer? So all I want you to do for the rest of these is I gave you the equations that we used, and I gave you the answers so that you could check it. So all I want you to do is you're going to have to manipulate some of these equations a little bit. Like this guy, where you're going to have to distribute and set it up so that it says x, y equals, and the same thing with this guy, equals a constant. You're going to have to set them up so that they look like a matrix, and then see if you get the same answer. Okay? And at the same time, see if you can flip it back to a fraction.